Select the major product of the following reaction sequence. So we are given as a starting material an alkene. And the first thing we are doing is we're taking it through this two-step reaction. So borane in THF, so THF, so this is borane. THF is a solvent, it is a cyclic ether. So that is a common solvent for this reaction. And then we're reacting in the second step with hydrogen peroxide and aqueous base. So overall, what these conditions are is the conditions for the hydroboration oxidation of an alkene. So hydroboration oxidation. And so what this two-step process does is it's a way of taking an alkene and making an alcohol. So it takes an alkene to an alcohol, and specifically it does so with anti-Markovnikov selectivity. So what that means is that the hydrogen, instead of adding to the least substituted carbon, the hydrogen would add to the more substituted carbon, which means the alcohol would be on the less substituted carbon atom. So the product of steps 1 and 2, that hydroboration oxidation, would be an alcohol. Right, so we've added a hydrogen here and an alcohol to this carbon. So we have an alcohol after this first set of reaction conditions. The next thing we're doing is we're treating this with bleach, essentially. And so this is a mild oxidant. And so what this is going to do with a primary alcohol is it's going to take that primary alcohol and it's going to convert it into an aldehyde. So at this point, we can go ahead and select the aldehyde that would form. So that would be A. But let's take a look at how this reaction actually works. So if you have an alcohol, okay, and you are treating it with bleach, this is hypochlorous acid. So that's an acid, and your alcohol is a base. It is a weak base. So the first thing that can happen is that your alcohol can act as a base and it will be protonated by your acid, the hypochlorous acid. And so what this is doing is it's making that poor leaving group, OH is a bad leaving group because it would be hydroxide ion, a strong base. So it's making that poor leaving group into a good leaving group because it is now protonated. So if it were to leave, it's going to leave as a neutral water molecule. And we generated a nucleophile right here, which can kick this off as a neutral water molecule. So we have the anion that we just formed, and it's going to do essentially an Sn2 substitution here to kick off the water. And so we have replaced that, we've kicked off a water molecule. To do the oxidation, to get to that aldehyde, we need to remove a hydrogen right here. Right here, this hydrogen, one of these two hydrogens, right? Because this is where we're going to form the double bond. So this step is gonna look almost like an elimination. So we've got the water that was just liberated, and there's also, this is an aqueous solution, so there'd be a lot of water around anyhow. So we can remove one of these protons. The hydrogens are going to come in to form the double bond. And on that oxygen, you have chlorine, which is a good leaving group, so we can kick that off. And so that's how we are going to form the aldehyde in this reaction.